So hello everyone, I'm Robby. I'm an engineer at Facebook. I work in ads interfaces at Facebook, so this is the part of the website that advertisers use to create ads. So I'm not directly responsible for all the annoying advertisements you might see in your news feed, but indirectly, kind of. Sorry, we're working on it. So the thing that I want to talk to you about today is building AST-based code mods, essentially refactory tools for everyday use, and the keyword is everyday. So to start, I want to introduce you to someone. This is Robby. He's an engineer at Facebook on the front end, working in ads interfaces. Hopefully you don't recognize him. This is me 2 weeks ago. I'm not looking very enthusiastic. The reason is I had a problem. I just finished shipping a new feature in ads interfaces. So to give you some context, when you create an ad on Facebook, you can specify a placement for that ad. So this is essentially where it shows up in the network. It could be Facebook newsfeed, it could be Instagram, a few other places. And we wanted to sort of change the way this UI looked, restructure it a little bit to sort of fit the way that advertisers use this in our flow. And then we also reorganized a little bit how placements were represented in our code base and the logic and the validations associated with it. So like most new features at Facebook, we didn't launch this to everyone all at once. That would be too many billions of people. So we used something called a gatekeeper. So this is basically a Boolean expression that you can use to fork execution paths in a code base. So when we initially launched, we launched to 10%. And so 10% of people hit this if statement, and if the new feature was enabled, it was true for 10% of the world. They executed those statements in their browser, and 90% of people executed the next few statements. And then we launched to 50%, and then 50% of people executed the first few. And we did a lot of statistical analysis to make sure that this was the right feature for our product and it wasn't making people drop out or anything. And then we launched to 100%. So awesome, I'm done, right? I can move on. I'm kind of tired of placements. I want to move on to some other cool project, and my manager thinks I should as well, and I happen to agree in this case. But as I said before, I have a problem. I spent all summer long adding checks like these in our code base. So I showed you an example. Here's another one where if this Boolean expression is enabled, then we're turning early from a function. Otherwise, we do some other stuff. Here's another example, a ternary expression, where if the Boolean expression is true, then we would assign something to a variable, otherwise assign something else. Another example, we might not just be checking this gatekeeper. We might be using it in some complex Boolean expression that doesn't get removed. But all of these other places, I have to go and clean up, right? I mean, we have a package we have to send to the client. We can't be full of dead code like this. There's just a few other places in our code base where this happens. I actually did run this command. Just a few other call sites that I have to go and clean up. So, some of you might find this enjoyable, therapeutic, deleting dead code. I mean, I kind of like it. I can see the appeal. You send a bunch of red commits to your team members. Destroying things is kind of fun. But I preferably, I sort of like to build new things. But I can't. I'm stuck. I have to spend the next couple weeks cleaning up the code base and all these call sites, 321 of them. But what if I told you I could do all of it, all 321, all the different kinds of expressions that I showed, the ternary, the early return. I could clean up the dead variables and functions and classes, all of it in under 2 minutes on that machine. That'd be pretty cool, right? So let's do it. So I'm going to use a tool called AST Explorer. You can go to this now if you'd like, astexplorer.net. And on here, I can parse JavaScript in real time and see the AST that comes out. So the AST is an abstract syntax tree. It's a data structure representation of the code that I write. So here's an example of some statement that might be in our code base. I'm setting a gatekeeper check, the result of a gatekeeper check, checking some feature called feature, and I'm sending it to a variable. What does this look like if you parse it into an AST? Well, over here I see that is a variable declarator, which has an identifier whose name is x, and it's being initialized to a call expression whose callee is gatekeeper check, and which has an array of arguments, the first of which is a literal with the value feature. So this is cool. How would I write code to access this? Well, I can go ahead and open up JS CodeShift in the AST Explorer. So JS CodeShift is a tool that we developed at Facebook, essentially a wrapper around a lot of existing libraries that allows you to parse and traverse the AST. So really all it comes down to is a function which takes in the source code of the file above, this file, the input file. I can access with file.source, and an API for accessing JS CodeShift. I call the J function, I've just assigned it to J for brevity. I call it on the source code, I get an AST, and if I wanted to turn that AST back into executable code, I just call it .toSource, and that's what you see on this panel over here. So the input and the output are exactly the same right now because I'm not doing anything. I'm just parsing it and then putting it back into source code. But let's say I wanted to do something like, ship this feature. It's out there. It's essentially, I'm setting var to true. Like that's what this code reduces down to. So let me do that replacement. I'm going to take my AST and I'm going to find something. What is it that I want to find? Well, it's a call expression. And I need to describe the structure of this expression. It has a callee whose name is gatekeeper check. And it has an argument list. The first of which has the value feature. And I want to replace this structure with a literal of just true, right? So there, I did it. Now, if I had changed this to something like, so you can see over here that this is replaced with true. If I change this to something like gatekeeper check 2, that does not get replaced. It doesn't meet the criteria that we described. Or if I changed it and used a different feature, like feature 2, of course, that also doesn't get transformed. So that's cool. But everything I've done so far, you could probably do with regular expressions, right? Like you could go through and find and replace. It might be kind of hard. You'd have to deal with some white spaces. This could be double quotes. Who knows? Let's see, what else? It could have a trailing comma. Just don't forget that. This whole thing could actually be in a comment. If I don't want to transform that, notice that the transform that I've written here handles all these cases. It could also be, a multi-line string. Who knows? This is how we do multi-line strings in JavaScript. I don't want to transform the contents of strings. I could have comments inside the code, like, hello. Good luck writing your regular expression that handles those cases. But you could do it. You're smart, right? You could figure it out. I'm sure we have someone in the audience who's probably written a book on regular expressions, and I'll leave it to an exercise to the reader to figure that out. Instead, what I'm going to do is something that you absolutely cannot do with regular expressions. Maybe a more realistic check that I might have seen in my code. Do something if the feature is enabled, otherwise, do something else. Once I ship this feature, all I really want my code to look like is just do something, right? I just want to call this. I don't want any of the other, I don't want to have this reference lying around or anything like that. So I want to do some AST trivia for you, if you're into JavaScript. Who of you know what the name is for the statements in an if statement, if the condition is true? So I'm talking about this, or if there is multiple ones, the series of block statement, the series of statements if the condition is true in an if statement. Does anyone happen to know? Just yell it out if you do. Anyone? Any guesses? No? Say what? Expression body. That's a good guess. No? Say what? Adent. Adam? Another good guess? Well, let's just look. I don't know. Apparently, it's called the consequent. I'd never seen that word in singular before. Usually you say the consequences of something. If this was a series of statements, you might think these are the consequences of executing the if statement. But no, it's consequent. And this is the alternate. So what I really want to do in this case is replace the whole if statement with the consequent of the if statement. So, like I did before, I'm going to find, what is this? An if statement. And it has a test as part of the if statement. The value is true. And I want to replace this with something a little bit more dynamic. So before I just said a single literal, here I can actually use the node that I'm traversing through in the AST to figure out what to replace it with. I can pass a function here. I access the consequent by doing this, node.consequent. And it's a block statement, so I need the body. So there you have it. I've replaced anything else in the else condition. I've removed the reference to the gatekeeper check and replaced it only with do something. Now, realistically, I could have some other expression here, like I showed in the slides. I could have something like or F. In this case, you and I can look at this code and know for certain that there's no way do something else is ever going to execute. So I really need to reduce Boolean expressions. So let's do that. What is this? A logical expression. So I'm going to find the logical expression. Describing the structure of the logical expression. It has a left-hand side, a left. The value is true. And the operator of this is, of course, or. And I want to replace this with just the literal true. So to make it more obvious what just happened, you see that the contents of the if statement was replaced with just true. And I could do the same thing with X over here. I could say something like or G. And that also gets transformed to just true because gatekeeper check is shipped. It's true. So there's no need to execute or reference any other code. So this is pretty cool, at least I think it is. I might realistically have imported do something, or also imported do something else. And in this case, I really want to remove any references to variables that are no longer used, or any declarations that are no longer used. So what I'm going to do is I'm going to search through the AST after I've done all these replacements for variable declarators. This is a variable declarator, right? And remove them. Boom. That cleaned up the code. Well, X, I could have removed X. That's fine. It's not referenced anywhere. It's not used. Do something probably shouldn't have been removed, so I probably should, filter this stuff out. And here I'm going to access the node and analyze it to decide how to filter. What I'm going to do here is find all identifiers in the code and check to see if there's only one that uses the name of this given variable declarator. Because if there's only one that uses that name, then I'm guaranteed that that is the declaration of the variable itself. And that means that it's no longer referenced anywhere else in my code, which means that I can remove it, right? So if 1 is equal to the number of times this particular identifier is used in the code, how do I do that? Well, I can search the AST for identifiers. If I can spell, whose name is the name of the variable declaration and the number of things. And size, the number of instances where this was found, this structure was found. So there you have it. I've cleaned up my code pretty well. Removed all unused variable declarations, cleaned up the if statements. I could keep going with this. I could iterate over all possible Boolean expressions. I could say that not false is true and not true is false, and anything, it doesn't have to be the left-hand side, it could be the right-hand side. Anything with a true and the or is just true, and I could do that recursively. I could go through and loop over until nothing about the AST has changed, and only then dump it out to source. I'm not going to do that in front of you. I already see some people yawning. So instead, I'm going to give you a pointer later on in the talk to a place on GitHub where you will find the script that does all these things. So this is actually a true story. 2 weeks ago, I did have this problem. I needed to ship this feature. And I did run a script just like this. I ran it against all 300 and something call sites. I broke a few unit tests because although our code base was ready for this feature to be shipped, our unit tests were not, so I had to go and manually fix those. But the fact that I was able to do this huge, gigantic one red commit for all the call sites of this feature, I think was pretty cool. So hopefully you're somewhat convinced that this is a useful tool for the application that I've shown you. We actually do this a lot at Facebook for our open source projects. So for example, React. React is a framework for rendering UIs. We've developed it at Facebook, open sourced it, and occasionally we break things about React. We launch a new version, or we want to discourage people from using some bad practice. And so we can't do this at Facebook, encourage people to migrate their code. Like, that doesn't work. You can't just add lint rules everywhere and ask people to do things. They don't. They ignore them. So we just do it for them. We just write transforms to go through our code base and update call sites to better practices, or to use the unbroken version. And this is one of my favorite transforms. So this is a repository of transforms using JS CodeShift. The class transform. So we did a poll internally about what bothers you the most about React. And one of the answers was the number of ways that you can use it. So React is fairly mature. It's been around for a couple years. And being around for a couple years, it's had to cater to lots of different kinds of developers. There's the functional folks who prefer number 1. There's the people who prefer inheritance. It's number 2. Number 3 is the traditional way to use React. And if you don't know anything about React, you might be confused at this point. Why are there so many ways to use it? If you've used React before, you're probably also confused about which one you should use. We're certainly confused internally sometimes. So we decided to change all the places that use 3 to use 2. So you can imagine from just looking at the code what that kind of transform at the most basic form would have to do. Transform something that uses an object to something that uses a class. Lots of little cases that you'd have to handle in that situation. But we did it. We used this code to do it. And I'm not looping this video. I'm actually just scrolling through the transform that we ran on React Native. In total, there were about 12,000 call sites that we updated with this transform. That was in React Native and also internally. And there's two really cool things, I think, about this. One is that it's vast. I mean, you would never actually do this yourself. This is not a case where you have to clean up, you have to do it. No, you would never actually want to migrate this manually. But we can with AST-based code mods. The other cool thing about this is that I think what you're looking at right now is the beginning of the end of breaking changes. When you create a framework or a library, you often don't see the full set of use cases that you might have or the implementation that you might want. And you'd want to change it sometime later on, right? But then you'd hesitate because of the number of places that it's used, the difficulty in getting people to migrate to the new way of, the better way of doing things. But if you publish a transform with your chain set, it greatly increases the barrier to entry and the use of the newer, better version. At some point, I just gave up and stopped scrolling. I could keep going, but. So we do this a lot at Facebook, but we're not the only ones. Some folks outside have caught on. Ava is a awesome test framework for JavaScript. They actually have a repository for migrating from one version to the next. So if they publish a new version, they'll update all your test cases to use that version automatically. They kind of started a war, though. There's another group that wrote a set of code mods to convert Ava to Jest. Jest is another test framework for JavaScript. And now there's an issue open on the Ava repository for converting Jest tests back to Ava. So, open source drama. My point here is not to convince you that there's a lot of frameworks in JavaScript. I think that's pretty common knowledge. But there's a couple of things. One is that this idea of building tests should really outlive the testing framework that you use, right? Your goal is not to use the latest, greatest technologies out there, or they enable you to do a lot of cool ways of testing. But if you want to migrate your code to use a new framework, you now have the ability to do that without worrying about any differences in that framework. The other is that, if just a hint, if you have some project and you want people to use it instead of the most popular one, just write a set of transforms that will convert everyone's code to use yours, and it's great, right? It reduces the barrier to entry significantly. Even the NFL uses code mods. So the NFL is the National Football League. That's real, American football. So the American National Football League has a bunch of websites, of course. And they use code mods. They use React. They use some of the React code mods I showed you. But they also did a bunch of their own to migrate their website to use the latest, greatest frameworks in various ways, routing, testing, etc. So now you have no excuse. They did it, right? So another thing I want to talk about is how weird JavaScript is. So this, in any other language, would drive you crazy. This doesn't make any sense, right? Well, it does in JavaScript because we don't have block scoping for vars. They're function scoped. So this var x is actually being hoisted to the top of the function. Luckily, though, some folks working on the language added some cool features called let and const. So now, yes, finally we have a way of writing variable declarations like everyone else does. So the people coming from other languages won't be totally confused about JavaScript. But like many new features of the language, people are going to start using this. They'll try to evangelize it on their team. Some people will be the holdouts, like they're going to keep using vars because why would you use 2 words when you can just use 1? Or const is 5 characters. Var is just 3. Come on. Eventually, they'll change their minds. But wouldn't it be great if you could just, I think you know where this is going. Wouldn't it be great if you could just convert the whole code base overnight to use let and const? That would be awesome, right? So yes, we have a code mod for that. JS Code Mod is a repository for just JavaScript-based code mods. There's a ton of stuff in here. One of them is a no vars, which you can imagine what it does. It's just 200 lines of code. I could copy paste this and run it in the AST Explorer. But I'm not going to do that. Instead, I'll just run it on an actual repository, and y'all can check out the pull request. How about that? So I was trying to figure out which repo I should do this on. I tried to think of something that might be popular that most of you would know about. I consider jQuery. I'm not that ambitious, especially in a conference, in a talk. Instead, I thought, well, meta is in the name of this talk, right? So I think what I'm going to do is run the code mod using JS CodeShift on JS CodeShift. Because it turns out, JS CodeShift, the project, started a couple years ago, and it was before let and const were really a thing. And we actually have a lot of vars in there. Some const and lets. I think it's very representative of a lot of projects out there right now. But let's just, convert it using it. So you can write code mods while you code mod. So you can have a code mod to code mod. Okay, so I'm not fooling you. I have a checkout of JS CodeShift right here, and I also have JS Code Mod transforms that I showed you just before. So let's speak. Code Mod demo. So let's do this. Bin JS CodeShift. I'm going to pass a transform from the JS Code Mod repo, the no vars. Run it on source. Sound good? So I'm actually executing JS Code Mod or JS CodeShift on itself using a transform that uses JS CodeShift. Just want to get that across. It's pretty cool, guys. So what's happening right now? Well, I showed you the AST Explorer running a transform as you add code in real time. What this is doing is parallelizing the work across, you have a bunch of processes across your whole code base and running them on each file individually. And I paused it, but it took 12 seconds, which is great. I see that it changed 16 files right here. Let's look at it. What did it do? So it didn't tell you much about let and const. If you don't know JavaScript, const prevents you from rebinding a variable, so sort of immutable binding. So in general, immutable is great. I agree. We don't really have immutability here, but in general, it's nice to know that something's never going to change in your program. It's just nice to read. So we're going to err on the side of adding const, okay? Which is going to make that decision right now. And if something changes, and only if it changes, we'll use let. So here, for example, result is reassigned. So we have to use let. Otherwise, we use const. And you can imagine in some cases things might be needed to be hoisted here. It doesn't. So this is declared in a block and it's a let. It was originally a var. We happen to know with our code mod that this variable isn't used elsewhere outside of the block. So we can just safely use let here. Cool. Let and const. Hopefully my coworkers understand what this is about. Oh no. Sorry? Now you can know that I tested this out a couple times. Let's see. It's already here. Nice. Compare and pull request. Ship it, not shit. I knew I would do that. Writing JS code shift so many times. Cool. So this is all real. You can go check it out on the JS code shift repository under pull requests. I hope you'll check this out. And all the code is available, so you can see how that worked. So I understand not all of you are big fans of JavaScript, which is totally fine. There are tools that exist for other languages. This is not my area of expertise, but PHP does have a parser for PHP you can use. Python actually has AST library built into the standard library, which is fantastic. It'd be great if JavaScript had that. There's some stuff you can use for other languages. I don't think the tooling really exists to the same extent. So one of the points of this talk is that if you like what you see, you should drop everything after this talk, after the conference. There's some really cool talks coming up. So after the conference, and go build it for your language, because this is an incredibly useful productivity tool. So yeah, I hope I've convinced you that code mods are awesome. And thanks for letting me speak here. So at this point, I want to open it up for questions if you have any. And we have a mic up front, so just raise your hand and get my attention in some way, and I can point them there. Any questions? Yeah, right over here.
Yeah, very awesome what you just demoed. What about comments within the code that you're modifying? Does it preserve that, or just delete them, basically?
Sometimes it does preserve it. Sometimes if it's embedded in code that is deleted, it's part of the AST itself. So the comments are attached to the nodes. So if the nodes are deleted, then the comments will delete. If you delete like a line of code, sometimes it will delete the comment above it. But I showed a couple of examples, I think, where I replaced a statement in an expression in a statement. The comment was out to the side, and that was preserved. So most of the time they are, unless they're actually attached to like inside embedded in nodes. Yeah, good question. We actually have there's a legacy sort of way of describing types that we've used in the past, where it's essentially comments. Before we had really good frameworks out there, we just used comments for everything. So one of the efforts right now is to actually go through the AST, find those comments that describe the type hints, and convert them to a different framework that uses type hints. So yeah, definitely useful. Any other questions? There was one in the back.
Hey, great talk. My question is, what are the limitations of AST? What's the things that it can't do?
Yeah, so limitations of at least JS CodeShift is that it operates on a single file at a time, right? So when you could throw all the files in your entire code base into one and then analyze the entire AST that way. But oftentimes what you're doing is a single program. That gives you a lot of limitations, like you can't check across files. Is there no longer a reference to this module? I'd like to delete it, that kind of thing. So yeah, in that sense. And in general, I think you'll encounter some issues with an AST is sort of like a machine representation for code, and us, unfortunately, we're not machines. We like to style things in certain ways, right? We have conventions, and that I think is another big limitation. Is once you transform something into an AST, it's difficult to transform it back and add new code that adheres to the style of the code that you wrote before. So you can try and do a few things to fix that if you can sort of codify your style, but that information is sometimes lost. I think JS CodeShift and Recast and some of the libraries that we're building on top of helps preserve style as much as possible, but there are cases where it can be a pain point. Yeah. Any other questions? Yeah, over here.
Hello. Yeah, it sounds really powerful. You can integrate with grunt and stuff, so just transform as you push. But would it replace lint, JS lint? Like if you have code standards, you could just force the standard, but
yeah, like unused variables, for example. We could enforce this in some way. Yeah, I mean, code conventions can be debated is the issue. So I had a friend who had a big debate about a certain convention at Facebook, and in order to win the debate, he ran a code mod to convince, oh, look, the number of call sites that use this now. It's not a great way to win a debate. So I think, yeah, so some things can be definitely enforced, objectively correct in certain ways. But I definitely think there's still a role for lint, just for, in case there's false positives. You can write a lint rule that might come up with false positives. Doing that with a code mod is a little more dangerous. Yeah.
Yeah, thanks.
Yeah. Yeah, John.
So naturally, with a Facebook talk, I'm always going to talk about something from Google. Google has a project called Refaster, which there's a paper out. I know I can talk publicly about it because there's a paper out there, where instead of giving it transforms on an AST, you give it an example of, this is what the code looks like before, this is what it looks like afterwards, with the benefit that then the person writing the refactoring doesn't need to understand ASTs and go into great detail. Is there anything like that that I would imagine could be built on top of
Absolutely.
all of this?
Yeah, so definitely. We're always looking to make the API a little bit easier to use. Describing what the code should be after your transform, I think, is somewhat difficult. I'd have to look into this project. I'm fascinated. If it can be done in a really nice way, we should definitely steal those ideas. But because you often have to do some programmatic, like this, the way that I did this right now, I specifically took the consequence. I had to take the body. If it was a block statement, I would have to make sure not to take the body and only the consequence. So there's a lot of programmatic stuff there. But describing the code that you actually want to replace, I did this with a JSON structure. You could definitely do it with code and then parse it and then strip out location identifiers and just use the structure. I've done that myself in a couple places just to make it easier. So yeah, that API is definitely something I think we'll consider adding in the future. But I'm really interested to hear how it works with actually representing the code that you want to go to. That sounds really cool. Yeah. Nice. Any other questions? No? All right. Awesome. Well, thanks for having me.